Will you do that? Okay, thank you. Okay. As we said in our last webinar, if you have any question or you want to clarify something, please use the button raise your hand, and we will direct your question. Don't forget to unmute your microphone during the presentation of the trainer, and of course, when you want to speak, to unmute your microphone. And now we will start the presentation. So I would like to call my colleague Julie to start with her presentation, starting from what is the objective of today's presentation, of today's webinar. Thank you.
Thank you, Thanos. Hello, everyone. Nice to see you again. I don't know if we have someone that is just came to these webinars, but if so, you need to know that there is no problem if you haven't already seen the first webinar. You can, we can share this information with you, and you will not have a problem. Before I start with the new webinar, I would like to ask all of you if you have any questions regarding the previous webinar. If you've seen the video, if you checked your questionnaire, if something really didn't fit, if you have any questions, please raise your hand so I can see someone has a question, and then again I can answer or move on. Okay, no hands. Good. Now, I'm going to start sharing my screen. And this is today's presentation. So today, we are going to see the basic hardware around the 3D printer, and I'm going to guide you through some steps you need to do, like fine-tuning your 3D printer in order to have a quality first print job. So today we're going to see the basic parts of a 3D printer and how those parts are related to your print and with each other. And finally, we are going to see how you can start printing from scratch your already given STL files from the manufacturer of your printer. Before I start, I would like to ask if you already have a printer at home or at school. I would like to know that. So if you have a printer, please write it down and write the model if you can. If you don't have, please again inform us. Okay. Okay. A 2, okay. You have a very nice living room, Stella, with 2 printers at school, yes.
And probably a very nice husband.
Stella has the printers, I don't understand.
Yes, but his husband, okay. Let Stella have 2 printers in her living room.
Yes. He, very good boy. Reality ender, good. Okay, we got the picture. What I wanted to say regarding this is, I understand that having a printer, maybe it's difficult for some of you, especially if you have the printer in school but not at home, because at first you need to really get into this machine. You really need to take your time and think these things through and understand how this thing works. So maybe if you have it at school and the principal is allowing you, maybe you can take it to your home and spend like 2, 3, 4 hours and trying to understand the machine you're having. Again, if you're trying to buy one, try to make all the arrangements for your home and then take it back to school, because I think you need to have a clear head so you can start. That being said, I'm going to try to resolve all these first beginners issues you might have with the hardware, and try to show you that the machinery is not that intimidating. It's very easy if you know what to do. I had no idea what to do. I'm not mechanical like Thanos or Yorgos. I'm with electronics. But it was pretty straightforward for me too. But I had the time. I had the machine in my home. I had the time, so I could really focus on that. So this is the printer I have in my home. This is an FDM Tornado. It comes in a box, as most of the printers you are going to have. They come partially assembled, and then you have to finally assembled by yourself. It's not that hard. It has instructions, and in this case, internet is much of a help. I had a video with a little guy showing me what to do, and then it was very easy for me to assemble this 3D printer. This 3D printer is called a Cartesian 3D printer. That means that it prints in the XYZ Cartesian axis. And if you see here, this is the bed, so it moves to the Y axis, and this is the X, where is the extruder is. Let me show you here. This is the X axis, the extruder. This is the bed, the Y axis, and this is the Z. I'm going to share some videos with you so you can see what is the difference between different 3D printers, FDM 3D printers, because we already decided in webinar 2 we're going to use FDM printers. So other printers are the Delta printer, where you can see that it forms like Delta, it's a Greek letter. And this is the Core XY printer. Because it's difficult for me to explain in English and for you to understand, I think the videos will say what is what more easily. So let's see the Cartesian. I have already shown you this video to my previous webinar. In this video, I would like for you to observe, if it's possible, because I think I have internet connection problems here, that the bed where the printer is moving back and forth. It's almost like the nozzle, it's pretty steady, and the bed is doing all the job. Is clear for everybody that the bed is moving back and forth, back and forth? Can you see it from the video? Not really.
Okay.
Okay. Let's see. Now we are having the Delta printer, which is a whole different thing. As you can see, it has 3 bars, and they are moving just vertically, up and down, up and down, up and down. These 3, I don't know how you call this, these 3 things, axes moving up and down. Finally, they can create a whole object. in all 3 dimensions. Of course, it's a much more expensive printer, but it does an amazing job. You see here the screws. I'm showing this because our printer has 1, 2. They're called the lead screws. Here you can see them very clearly. And finally, we have the Core YX printer here. The main difference from the Cartesian we're using back at home is that in this printer you can see the bed dropping. Every level we are making, the bed is dropping and dropping and dropping. So the bed is not moving back and forth, but is moving up and down like in the Z-axis, not the Y-axis. That is the main difference, and that actually makes this printer faster than the Cartesian we are using, the FDM Cartesian. But because of money issues and because these Delta printer and Core XY are very hard to assemble comparing to the Cartesian, we are using the FDM Cartesian printer, all of us, I think, at home and at school. If someone has a different printer, I would like to know. So let's start with the hardware. First of all, we can see the frame. You can see those yellow lines here pointing the frame, meaning the metal parts of the printer. The frame is actually where the basic structure of the printer. On the frame, you can have all the different parts needed so your printer can print. The frame is different for every printer. You have closed printer, you have open printers, you have the Core XY printer, but mainly it's made from aluminum and steel profiles, these bars. You will buy these bars and you can make the frame of your printer. That is why when you print and your nozzle is start printing and the motors start running, you have a lot of vibrations. These vibrations can be absorbed by steel and aluminum profiles. If you had something else like wood or plastic, some people print their printers, you won't get such a quality print jobs from your printer. Durability is the other matter. I mean, you buy something costs like, I don't know, 400 euros, you want to be durable. Second of all, we have a hand raised. Okay. Who raised the hand?
It was me, Julie.
Ah, okay. Sorry.
I would like to add something for all the participants. As today topics for those that are beginners or having no experience about 3D printing, maybe it seems too difficult and too complicated for them. Please feel free to raise your hand and ask questions during the presentation of Julie. Usually, we recommend to keep your questions for the end of the presentation, but today's topic, it's too technical. So for someone who has no experience, maybe it would be too difficult to wait to ask his question. For example, what is the extruder, what is the hot end, to wait at the end of the presentation. So if anyone wants, please raise your hand and we will answer your questions, okay? Okay, Julie, do you agree with that?
Of course, yes, I do.
Okay, thank you. You can continue.
Yes, given the opportunity of this break, I am uploading right now to the chat room a small PDF file with terminology or glossary regarding some terms about 3D printing. So you can advise that, or maybe you can keep it, you can print the final page, which is about the 3D printer, and keep some notes. because I do understand that this is all very unclear for you, but I hope I will clarify them by the end of this presentation. I'm using all these unknown terms right now, but I will make sure that you really understood what I'm saying by the end of this presentation. So I'm sharing my screen again, and now I'm going to introduce you the basic parts of the printer and explain why these parts are here and what are they doing. First of all, we have the bed. The bed is the surface where your object is being built on. So the layer by layer by layer is on the bed. The bed is moving to the y-axis. I'm going to show you a video a little bit after that, and is heated. That means that the bed should come to a specific temperature in order for you to have a quality print job, a succeeded print job. Why should this bed be heated? I'm showing you here two examples. This is an object print in a bed with no heat, and this is an object print with a bed with heat. I'm pretty sure if you had to choose, you would choose the black object instead of the orange object. Why this happened? When you print, your material is very hot. So you can understand that at the middle of the object, temperature is still high, but at the edges, like here and here and here, cooling starts to happening a lot sooner than the cooling happening here in the middle of the object. That's why the edges tipped off. This is called wrapping. Wrapping is a term that we use a lot in 3D printing, and you don't want that because in this case the print is destroyed. So that's why we prefer to buy printers with heated bed. They are like 100 euros more expensive than the other, or 200 maybe, but it will save you a lot of time and a lot of destroyed prints, so a lot of PLA wasted. How is the bed before, when you take it pre-assembled? You have, this is an aluminum surface. This is the electrical circuit that actually heats the bed. This has been put, this surface, which is a moving surface. And how this is moved, it's moved with these little wheels called the rollers and a belt attached to a stepper motor. I will explain everything about these unknown words in a little bit. But you can see that you have a belt, we have the rollers, and these rollers push these things forth and back, forth and back. Is my mouse pointer clear for you? You can see the mouse pointer? Good. After you assemble the bed, which is, I think in most printers come pre-assembled. You shouldn't have a lot of things here. Thanos, if you could mute the. You unmute me too. Good. So you can see what's on the bed. Different manufacturers offers you different choices of what to put on the bed, so you can have your objects actually print nicely on the bed. Some of them they have glass, some of them they have a magnetic shield. Some of them they have this green thing which my Tornado came with, which is, I don't know, it's not, it was not magnetic, it was glued on a glass surface. And this is what I have done for my printer. When my Tornado came, it something like that was on my bed. It was the print test of the manufacturer. So I could understand that my printer was assembled in the factory, tested, and then disassembled and put it in the box so it came to me. I was a very rookie and a beginner, had no idea what 3D printing was, so I was looking at this stuff and I was wondering, can I peel it off? Should I leave it on? I had no idea. At some point, I understood that there's no point for this to be on my bed. I peeled it off and then this came. With this surface, I made like, I don't know, like 2 months of print, no more, and then it started wobbling. So I couldn't really print anything. I removed it from my glass bed. I was cleaning my bed like for 2 days because it was a very hard glue on it. And then I had a very, if you see this glass, this is a very dark glass. My bed was actually glass. Because I didn't really trust me, I was doing some experiments, and these experiments had my nose hit in my bed, and I was really afraid I was going to break my bed. And the bed is not something you want to break. It's expensive to buy another one. So I decided to put on a simple glass. Like 4 years ago, 3D printing was not that famous here in Greece. So this is a good glass coming from the manufacturer, which it cost more than €5, which I had paid for my glass, and it's suitable for the printer. I bought a simple glass. I'm telling you all of this because I know you will find them in the internet, and I know most of you will do these experiments by yourself, and I just need to give you feedback before you try it. So if you're going for the glass, better to choose something that is suitable for 3D printing. I went around the corner, I paid $5. It lasted like, I don't know, 2 weeks, and then it broke. So again, I tried to find another solution, and again, internet saves my life. So what did I do? I bought some IKEA mirrors. Those mirrors are like 4 for €10. I printed this bracket so the mirror can stay in place. I have the loss of printing surface, if you see here, and at the back I have lost like 15 centimeters from my printing space. And I have this thing going for 3 years now. Nothing happened to it. I have never needed to choose to another mirror. So I recommend mirror if you don't want to pay something extra. Mirror because it's, as I have proven, it doesn't break, and it can really saves you from bed wrapping. So what is bed wrapping? Your bed, when you start, I will say that in bed leveling, but I'm saying here too. If you see from the same height your bed and your eyes, you will see like your corner is slightly higher than the center of the bed. That is called the bed wrapping. Again, the wrapping term. This happens to almost every printer you're going to buy. So if you want to save yourself from severe bed wrapping, maybe you should choose a mirror to put on. Again, the most common trouble people having with printing is that the prints do not stick on the bed. This is the most common problem you're going to face. So if you are on print number 1, maybe you need to find some solutions. These solutions are very easy and very practical, and people have done it for ages. Like you can put glue on your surface, either if it's magnetic or if it's glass or if it's mirror, just put some common glue. Of course, you can find in the stores like special glue for 3D printer. Well, it's just glue. Use your stick from your kids, and it will do the trick for you. Duct tape or Scotch tape is something we all have used in numerous tapes, I can say. and it's really very easy to stick the prints on the duct tape or the Scotch tape. So many people, at least at the beginning, they're using this. You have a downside that if you have a glass or a mirror, your base of the print will be very shiny if you leave the glass or the mirror. If you put the tape, it will be like a matte effect on the base of your print. So if you do not care about the base, if you do not care about how it will appear, use the tape freely. Again, if you are just a beginner, use the tape either way, just to get started, just to understand what's going on with your printer, and then you will go to the part who says, I want to be beautiful, I want to be shiny, it's the next step. Finally, people using hairspray. Yes, so the hairspray we have for our hair, or you can buy a special spray for printers. In this case, I would recommend the special spray. I tried hairspray with my printer. If you do it, if you have it at home and you say, okay, let's do it, put a piece of paper on top of the spray as you're spraying, because that thing sprays all over the place and you will get a really messy printer. You will have your extruder having problems, you will have your belts filled with the spray, you will have your control box sprayed. It's a mess. With the special sprays for printers, the liquid comes out like, I don't know, in a very delicate molecules. I don't know how to say this, but you don't have this mess around the printer. It's like vaporizing and sticks with a very thin film on the printer's bed. And it actually, you can have a very good stickiness on your bed. Last but not least, you should adjust the temperature of the bed. For PLA, I say it's like 50-60 degrees Celsius. For ABS, it's like 100 to 110. But if you are like me and you have put a mirror on your bed, raise this temperature by 10 degrees because you have a thicker surface and you need to adjust the temperature of your bed. Again, all of that is try and error. Try one print, see if it sticks, see when it's creating the problem, when it starts to come off the bed, and then you can understand after a few prints what goes wrong. For me, all the 3D printing is about observing your machinery works. Observe the first layer to see if something is wrong. Observe the printer throughout the print. I know the prints may take forever, like 1 hour, half an hour. You cannot always be there and watch. But at first, try to watch your printer. You will get a lot of feedback and you will understand a lot of things. So again, I'm showing you here in slow motion, I guess, that the print bed is moving back and forth in the y-axis. And this is the movement your bed is going to do in order to create your objects. So it's poll time and question time. Let's have our poll. What kind of printer we are going to use or buy if we haven't already. And please answer to the chat room if after you voted, if we are going to use heated bed or no heated bed printers. So we have just 16 out of 33. Most of you said heated bed, which is correct. So if you're just buying, have in mind to pick a heated bed printer. And of course, most of you chose FDM Cartesian printer, which is the one we are choosing. Just to get familiar with the terminology, and if you are out there to buy, to know what to choose. I'm going to end now this poll, and I'm going to share the results. And now it's the time for you to ask any questions that you may have regarding the frame, the Cartesian printers, or the functionality of the bed. Okay, I'm stopping sharing. So there's no questions? You haven't understood everything? Good. So I'm taking you back to my screen. So we're moving on. Now we're going to discuss about the hot end or the heated nozzle. You are going to see both of the terms used. Maybe it's unclear for someone which is which, but let's say it's the same thing, and we are going to clarify these terms in this presentation. You can see my hot end here is in the middle, and you can see up close with these photos. You can see there is one fan, two fans that actually are covering the nozzle, the hot end, and here is the heated nozzle, actually also covered with this blue silicone tab. I'm going to explain now what is happening inside the nozzle. So this is my nozzle, my hot end inside the fan. This is actually a hot end, and this is a diagram, so I can show you how things work. This red thing is the filament coming through the hot end. I'm guessing, do you remember what the filament is? I have a message from Paolo saying that I have something wrong with my picture. Thank you very much. I will see it and I will make it correct next time. Good. Does everybody remember what the filament is? Yes, I can say. Good. It's the filament is the plastic that comes in spools. For you, those of you who do not remember, and we are melting that filament in order to create our objects. So this is where the filament is inserted in the hot end. Here it is also. It's been driven through a PTFE tube, and it ends up to the heated nozzle. So there is where the filament is actually gets melt. The temperature for PLA may be at 190 degrees Celsius. When it gets melts from this nozzle, you have a fine, thin string of plastic coming out, and you can create your object. The heater here, the heater block, and the heater, you can see here, I will show you a better picture here, where is the better picture? Here, this is the thermocoupler. You can see this is the heat block that you have the heat for your nozzle, and this is the heat sink. Why we need the heat sink? Because if we let the temperature rise up here to this part of the filament, your filament will start melt down. So you won't have this fine, thin string of plastic, but you will have something we call oozing. And that means your filament will start dripping on the surface, on the print bed, and it's going to ruin your print. We have something called retraction. That means that when the filament moves from one layer to the other, or from one part of your print object to the other, the retraction holds the filament back, so you don't have something dripping while you move your nozzle. So if you don't have the heat sink, you won't be able to cool your filament down, and everything will start just melt. Everything will start melting without you being able to control it. That's why we have the heat sink, and that's why we are having this area pretty far away from this area, so the temperature won't, I don't remember the word, anyway, won't come up here. Let's see what I mean with this dripping. You can see I print here something, and which have some holes, some round holes, and some square holes. You see when the nozzle moves from one hole to the other, it leaves a dripping line. You can see these little dots. That normally shouldn't be there. This is dripping, this is oozing. That means I have my filament in a high temperature. I printed that thing in 220 degrees Celsius, which is very high for PLA, and that's why I have this dripping. You see here the fine, clean plastic lines I was talking about. This is how your filament should be spread on the print bed, and this is very clear, squares and the round holes, but you can see the dripping. This will follow my my print until the far end of the print. That means when I have the final project, the final object, I will have to the top surface these dripping lines like connecting my holes together. And that is not something beautiful. If you don't care, okay. But it's if you just watch your first 2 layers printing, you can start to understand what may go wrong with your print until the end. So you don't spend like 2 hours printing and then say, oh my God, I have to do it again. Just watch your first 2 layers and you will get a good picture. This is the hot end, how you can buy a fully assembled hot end. Of course, you can buy the parts by themselves. You can buy this thermocoupler. This is the responsible part for heating the nozzle. This is the thing that actually connects to this PTFE tube. In this tube, your filament is driven through the tube to your hot end. This is the heat sink, as I already said. This is the heat block, and this is the fan. So here you can see how is your hot end actually connected to your printer. We have removed the fan, so you can see the heat sink, you can see the heat block, you can see the thermocoupler coming from actually your control box to make your nozzle hot, and you can see the PTFE tube where your filament is driven through the hot end. For most of printers, when they come on the heat block, you can find this cotton tape, this thing. Of course, this is just tape, which means it's going to be ruined after a few prints. Or when I say a few, maybe it lasts for a year, but at some point you really need to get this thing off the heat block and change it. So you can again buy a cotton tape, or you can buy this blue tap I had in my nozzle, called the silicone covers for your heat block. Of course, they have a great durability. You don't have to really to change them all the way, and you can and you really need it. If you decide to remove the cotton tape and not to put something else on this, you will have your control box says that you are experiencing a thermal runaway. That means that your thermocoupler is not sufficient enough to heat your nozzle because you are losing temperature from this heat block because you didn't put something on the heat block, so you can retain the temperature steady at 200 Celsius, for example. Again, a tip: if you try to do something you see on the internet, like putting aluminum foil, please be very, very careful. Put the foil just like this, like the tape. Do not put the foil to touch this thing here, because you are going to create a short circuit. I speak from experience. I did that. I had a short circuit. I destroyed my thermocoupler, so I had to replace it because I had destroyed this tape. I didn't have this thing yet, and I needed to print. So I said, okay, let's do something with aluminum foil. It was good, no thermal runaway, but at some point the things moved, and I had a short circuit, and I destroyed my thermocoupler. So be very careful which advice you are going to follow from internet, and that you have fully understand what this thing does. This is actually the nozzle. The actual nozzle you are using, you can see it here, to print. I suggest when you buy your printer, buy like 10 of them and have it spare, because at some point the nozzle is going to clog, it's going to have an excess PLA. Of course you can clean it, but it's easier just to remove and replace if it's one of these brass nozzles, which is very cheap. Of course, you can have nozzles, steel nozzles, costing like 5-7 euros, which are very expensive. If you want to print somewhere like metal, wood, carbon, you need special nozzles. And of course, you need to clean these nozzles and not really replace them. Your printer, it will come with a nozzle at 0.4 millimeter. It is the standard nozzle coming with the printers. There is, sorry, 0.6 millimeter, there is 0.2 millimeters. Maybe you need to experiment with different sizes, but 0.4, I think it's going to do the trick for you, so buy some of them. The hot end now moves to the x-axis, so it moves left and right. I'm doing it by hand just to show you. And it moves to the z-axis, so it can go up and down. Since our bed is not going up and down, the nozzle needs to go up and down. Up and down is going with a screw behind. This is the screw. It's called the lead screw. As you can see now, I am turning the screw and the nozzle is coming up. I'm doing it here manually, but of course there is a motor that is connected to the screw, and it can be moved up and down. So now we have covered all the axes and all the movements with our part. How things are moving. This is all of the other small parts you can see in your printer, and you are wondering what this is, what is this and what it is being doing. So everything in our printer moves with the stepper motors. Stepper motor is something like this here. We have 4 stepper motors, 3 for the 3 axis and 1 for the extruder. All the stepper motors that are for the axis are having a small switch so the movement can stop before it hits a certain point. This is the switch, this is the limit switch for the Z-axis. You can see now as my nozzle is dropping down, this metal part will hit the switch and the motor will stop running. If the motor doesn't stop running, my my nozzle will hit my bed and maybe it will break my glass. So you need to have this very well adjusted so you don't really smash your bed or create a problem to your bed. If you hear a clicking noise saying that something is wrong with your printer and you cannot really understand what is this, please switch off your printer. Go to your control box and press the button to turn it off. Do that as fast as you can, and then you can clarify what is the problem. Don't listen to a bizarre noise, something like struggling to happen something. When you hear something like this, just turn your printer off and then take your time and find what is the problem. Don't leave it on. It may cost you, especially to the bed. So you can see here the motor of the Z-axis, and you can see that thing spinning is the one that holds the lead screw and rotates the lead screw so you can have the up and down movement for your nozzle. You can see it now more clearly. I don't know if you have been watching the video all this time. This is the lead screw, this is the motor, and this is the thing attached. Other than switches and motors, we have belts and the little, you can see here the little wheel, it's called the roller. This is the belt, and the belt is attached to the motor, and you can have movement to the X-axis. You can see here all the stepper motors. These are the stepper motors. This is how they're going to come with your printer. This is the stepper motor for the lead screw. This is the stepper motor for the X axis. You can see the rollers, the motor, and the belt attached to the motor. And this is, this is the motor for the Y axis. Again, you can see the belt, and the rollers are underneath your bed. Before I go to the extruder, again, I want to ask if you have any questions regarding the hot end or the heated nozzle and the motors and the belts and everything, because I know it's a lot, and maybe you have a question about that. No questions? Okay. So I will proceed with the extruder. This is the extruder in my printer. The extruder is the component that you can feed your filament in, and this part pushes the filament through your hot end. You can see there are gears here and the bearing. The gear rotates. This is the motor that rotates the gear. And the bearing here helps to move the filament, to push the filament inside your tube and into your nozzle. This is again a diagram of this. This is my extruder working. You can see here we have a little spring. This is the spring. I'm trying to speak very slowly. If something you have a question, please interrupt me. This is the spring that actually defines the area between the bearing and the gear. So if you have a filament and you want to be pushed through, this gap here must be exactly at a certain point, so it can be pushed through your nozzle, but at the same time, it's not destroyed from the gear. So the gear is not actually grinding your filament. Or, at the other case, you need to have this area between this space between your bearing and your gear, not really wide, because again, your gear cannot actually grab the filament. What is going to be the problem if those things happen? You're going to experience under extrusion or no extrusion at all. This is a grinded filament. So you can see it if you hear your extruder clicking, click, 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 you can understand that your gear is not really holding to your filament, it's not pushing. Or you can see it if you are away and you didn't really hear anything, you can see it at the final print. This is an under extruded final print. If you see no filament coming out of your nozzle and your nozzle is clean and not clogged, again, maybe you have this space between bearing and gear very wide, so you need to tighten this spring. All of these are tightened through this little bit screw. You can tighten, so you can have smaller space. You can untight, so you can have bigger space. If you think that you are printing PLA, so there is just one adjustment you should move, it's not really that true. Every PLA, especially even if it's from the same vendor but different color means different chemical consistency. So that means that you may need to change your adjustments for your extruder. You will find this on the internet a lot, saying that different PLA's color actually create different behavior for your printer. So keep in mind that maybe you need to readjust after you replace the spool. We have two kinds of extruders. One kind is the Bowden, this PTFE tube called the Bowden, and it's far away from your hot end. This is the one I have already shown you. And we have the direct extruder that is on top of your nose. So let's see that. This is the direct on top of your hot end, and this is the Bowden. They come with pros and cons. With the direct extruder, we have a very reliable extrusion, a very reliable retraction. If you remember, retraction means pull the filament back so your hot end can move without dripping on the bed. But you need a less powerful motor, of course, because the filament doesn't need to really cover this big distance from the extruder to the hot end. But you are going to experience vibrations on the hot end. And if you really need to change the hot end or the extruder, it can be really tricky. It's far more easy to the Bowden. The Bowden extruder have, of course, cleaner movements for your hot end, for your nozzle. It provides you a larger build volume for the Z axis, actually, because you have on your nozzle for the direct on your nozzle, this thing, the extruder, that really cuts some space from your Z axis. But of course, the Bowden really needs a more powerful motor or a slow response time. Given these things I've already said to you, I would like for you to vote which kind of extruder type would you choose? Twenty of you have voted. I will wait a little bit more. So I can see 21. Okay. I'm ending this poll. I'm sharing the results. And you have selected direct extruder. Well, I may need to disagree with you. The only reason, two are the main reasons I'm disagreeing with you. First one is that you have a very tricky extruder on top of your nozzle. So when you need to replace the hot end, the nozzle, or the extruder, it's going to be a very difficult task for you. And the second and the most important is that when you have the direct extruder on top of your nozzle, your prints are not going to be as good as you expected, because the vibrations are very severe, and you will have a wobbling final result on your printer. So because we are all beginners, we are all in school, I would prefer for you to choose a Bowden extruder for your printer, since most of you haven't already buy one. It will be much more easier for you to set it up, and much more, and you will have quality print jobs from the first print. You cannot really save your print jobs in the direct extruder. You cannot really do some tricks to make a better print, because these vibrations are unavoidable when the extruder is on the nozzle. So I would go for the Bowden extruder and not for the direct. The final thing we have on our 3D printer is the control box. The control box comes with a lot of commands. You can, and actually you can control your prints, the temperature, how your axes move, where it should be placed. And the manufacturer offers you a very good guide about what the control box can do. You can see control boxes built on the frame, or maybe like I have, that are separate from the printer. Control boxes are not something we really need to discuss. I think the directions given from each printer's manufacturer is pretty enough. So that is all the main parts of the printer. The next two videos and steps we are going to see is how for you to do the final fine-tuning so you can print. We have already said that you need a heated bed, that you have some choices about how the prints can stick to your bed. You need a Bowden extruder. What you need to do for your hot end to be ready to print, no clogs, having a cotton tape. So you have the basics, so you can start. This is, I don't know if you can see my printer printing, or the video is too slow for you. And now we are going to discuss about what we should do about the printer. So any questions here? I don't see any questions. Okay, good. Thank you, Christina, for the feedback. Let's go to these two videos are very important. The first one is about replacing the filament of your extruder. First of all, I'm demonstrate that you need to have a very steady desk, so that you can avoid all the vibration from the desk coming to affect the quality of your print job. Then you will have to prepare your printer. You cannot change filaments if you do not have your hot end actually being hot. You cannot do it if your hot end is cold. In my printer, I have well, like I cannot speak in English today anyway. I mean,
the choices.
The choices. Yeah, thank you, George. Thank you. The choices to print either the bed or the nozzle separately, or I can heat them at the same time. So I choose preheat PLA. I choose both of them, and you can see on the control boxes monitor that my goal is to capture 200 Celsius for the nozzle and 80 Celsius for the bed. This is the temperature rising as they are heated from the control box given the commands. You will see once we've reached the the temperature we want, and then I'm going to the extruder. Let's the video. Yes, I went to the extruder. I have this thing here, so the bearing is moving away from the gear, and I'm starting to pull my filament out. You can see I try a lot. I have a problem with this pull. I will discuss about this problem at the end of the video. At this point, you can see I'm pulling, and when it comes off, it's not that hard normally. You can see that it's partially melted. If you try to do it, then this thing is cold. You're going to destroy your nozzle. So heat it well, like in 200 Celsius, and then pull it off. Now I have the other spool of filament. I have to cut the edge to a 45 degrees angle, and then feed it through my extruder. I remove the filament from my spool holder. You should have a spool holder. You cannot really print if you do not have one. That spool holder came with my Tornado, not printed, but the STL file came and they recommended to print. So I did, and it was fine. I'm taking the filament and push it through the extruder. I have a very good angle later on this video. And now you can see what I'm doing. I'm pushing the bearing back, and I'm feeding the filament through the gear, the extruder, and then the PTFE tube until I understand that it came out through my nozzle. You can see here, it's a little bit white now, and then the red filament comes out. And that means the white is from the previous spool. But as you can see, it's not a thin plastic line because my nozzle is not cleaned. So you should clean your nozzle and push your filament through. And a fine, thin line should come out like that. If you don't have this line, and again, you have these curly lines summing up in your nozzle, then you may have a clogged nozzle. So you have to clean your nozzle before you start your printing. You should have this thin line dropping off your nozzle before the print starts. As I promised, I will explain what happened to the spool of filament. My filament is suffering from humidity, so it became very sticky. That's why I couldn't really remove it from my nozzle. I'm saying that because in your schools, you don't really have the temperature. Maybe it's too cold, maybe for my school it's too hot in the summer, and this actually affects the spool of your filaments. So if you are going to have filaments at school, or maybe you need to consider to first to end one of your spools and then open the other one. If you're going to be away, take the filaments back to your home. I do that every summer, because if we leave the filaments in the school for the summer, they become very dry, and then they break into very small pieces, and you cannot really print with them. If the humidity is the problem, like here, I keep in my home the filaments in a plastic box, and then I put in some of this silicone for humidity absorbers.
Silica gels.
Silica gels, or you can buy from the supermarket for your closet. You have some humidity absorbers for closets, which is very small, like small round boxes, and you have and you can put that in the plastic box. My humidity absorber is full with water all the time, but my filaments are surviving. This filament is out because I changed houses, and that became the filament destroyed actually. So filaments are very, very sensitive. Don't leave them out to dry. Don't leave them in humidity. Make arrangements with your principal so he can understand that you really need to move the filaments away from the school environment, which is not a very good environment for filaments, or have a box, put them in, put the humidity absorber so you can save your filaments. So this is part one for you to start printing. Part two is what we call the bed leveling. This is far more tricky to do. Let's see what we should do. What is the bed leveling? Bed leveling is what is the distance between your nozzle and the bed so you can have the best print quality. If it's too high, you will have an object that is not good with its dimension. If it's too low, you will have an object looking like squeezed. So you have to find the perfect distance between the bed and the nozzle. In order for you to do that, you need to preheat the bed and the nozzle. If you don't do that, you understand that you are going to print, and those things are going to be heated. All the elements, all the surfaces change when it's heated. So you should heat them before you start. Again, wash your hands because your bed is going to be hot. Now, the perfect distance between your bed and the nozzle is a piece of paper, like the one I'm demonstrating in the video. This piece of paper should really pass through bed and nozzle easily, freely, but not too freely. That means you should really find some the resistance. You can see me adjusting the bed because the paper didn't come through. I tightened the springs, so a little bit area created. Now I'm tightening a little bit more because again my seat cannot pass through this small distance between the nozzle and the bed. And again, I'm trying with the paper, and now we have succeeded this movement. This movement is very free. We don't want that. So again, I'm going to untighten a little bit my spring. I'm untightening now, and now you can see that the paper is running through the space, but not as freely. It has a little bit of resistance, and this is what you should do. This is the perfect distance between nozzle and bed. You should do it for all 4 corners of your print. Test it with the paper, and again and again and again. After you finish with all 4 papers of all 4 corners of your printer, you have to do it again. Again, go to the upper right, upper left, lower right, lower left, 2-3 times until you have the bed leveling as perfect as you can. Once you will see in the video, I'm going through this leveling. It's not really something more, but remember saying to you for the bed wrapping. So this is the problem here. You have leveled your corners, and you will, if you go to the center of your bed, you will see that the distance is far away from what you have been leveling so far. That is caused from bed wrapping. So if you're going to print an object that is going to be placed at the center of the bed, a small object like 10 centimeters, 15 centimeters, do this leveling at the center of your bed. Choose corners like at the 10 centimeters, 15 centimeters, and try to do the leveling there. In the bed wrapping, as I already said, it's very common, so you really are going to experience that. So choose the leveling around the center of your bed. When you buy your printer, your manufacturer is going to give you instructions about how to level your bed. But you cannot really print if your bed is unleveled. So those are the two steps you need to do. Feed your extruder and your printer with filament and level your bed so you can have good print jobs, quality print jobs. Then you can use the FTL files given to you in the SD card of your manufacturer, and they already have the G code in, and you can have your first print, and you can see how your printer is working, if it's working like it's supposed to be working. Again, for you that you're beginners, you're about to receive your printer, please do these steps, and if you have a problem, email us, send us an email, and we will answer back to you about your problems that you are experiencing. You will find it in the internet, an auto bed leveling way. This is with a part called the BL Touch. Give me a minute. I'm not going to show everything, but let's see. This is the BL Touch. The problem is that you need to do all the connections by yourself. You need to connect it to the control box. You need to connect it to the nozzle. I'm not going to show you everything, but I'm going to show you here the adjustment you need to do on the platform. So this is the BL Touch. As it moves down, this little switch stops your nozzle for heating the bed. And now you have to do some adjustments so you have the perfect bed leveling. So if you choose to use BL Touch, it's not something very easily done. You need to have some knowledge regarding connections with electronics, and then you need to fully understand how you're going to connect to adjust your BL Touch so your bed is fully leveled. But this is something you do once, and then you have your bed leveled for eternity. So for some people, this is something they prefer to do. I think that's it. It actually took me a lot longer than I expected. Yes, almost 8 to 10 problems is caused by leveling. Any questions? Good. If something hits you, email me. We will find the answer together. Thanos, back to you.
Thank you, Julie, for your presentation. Very interesting, this webinar about the hardware and the gear of a 3D printer. We watched today, the main topic actually was the structure of the 3D printer. It's very important for a beginner to understand all the gear and all the components of a simple 3D printer. I would like to highlight that because this project focuses on school teachers, we presented here in this webinar a very simple FDM printer. This is the aim. in order to be accessible for any school teacher. I would like to ask you again, if you have any question, please feel free to ask right now. Okay, I think Julie was a very good trainer, a very good presenter. I can't see any questions right now. Anyway, if you would like to speak to us later or have a question later, please free to drop a mail to info enabling. And I would like to thank you for another one time for joining us today. I will share with you now the Google form for the evaluation of the webinar. But have in mind that for the most of you, you will have also access to this form immediately when you will leave the meeting. And in addition, we will send you the evaluation form with an email in 2 days with the link of the recorded file of this webinar. Just a moment to share with you the evaluation form. So here you can find the evaluation form for this webinar. And of course, we will also send you the quiz for this webinar. We will always allow to you to have some time, not only for watching the webinar online, but also to have some time to study the recorded file in the website. And then we will send you the quiz, the questionnaire for each webinar, for the topic of each webinar. So that's all for us. We hope that you enjoyed this webinar too, and we hope to see you soon on the next webinar. So thank you all for your participation.
Thank you, Thanos.
Thank you.
Thank you and good night.
Thank you, Maria. Thank you.
Bye-bye.
Bye, Manuela. I can see some
Γεια
comments
σε
here.
όλους.
Γεια σας, γεια σας.
Καλό βράδυ. Γεια σας.
Καλό βράδυ. Ευχαριστούμε για τη συμμετοχή.
Καλό βράδυ.
Ευχαριστούμε πολύ και την Τζούλη για την πολύ ωραία παρουσίαση. Και εσάς για το coordination.
Να είστε καλά, ευχαριστούμε.
Good night, everyone. Bye-bye.
Good night, good night. Bye-bye.
Ευχαριστούμε πάρα πολύ.